Hello everyone, you're welcome to our channel once again. Today we shall be discussing on how to calculate the nozzle exit temperature of air passing through the jet engine. Now let's read through the question we have today. A jet engine nozzle has heat loss estimated 15 kilojoules per kilogram, while air passing through is accelerated from 136 meters per second to 223 centigrade to 348 meters per second. Now calculate the nozzle exit temperature of air in Celsius. Take the specific heat at constant temperature of air to be 1.0 kilojoule per kilogram Kelvin. Here we have a nozzle of a jet engine having the velocity 1, which is 136 meters per second at the temperature of 223 Celsius. At the entry, at the exit, we have the velocity which is 348 meters per second, and the heat lost as established in the question is 15 kilojoule per kilogram. Now let's pull out the parameters from the question given. We have our heat loss, which is exiting heat energy, 15 kilojoules per kilogram. That will give us 15,000 joules. We have our CP, 1.0 kilojoule per kilogram Kelvin. We have our temperature 1, which is the entry temperature of the air entering the nozzle, which is 223 degrees Celsius. We have to calculate our exit temperature at the nozzle exit. We have the velocity of entry of the air, which is 136 meters per second. We have the exit velocity of the air at the nozzle, which is 348 meters per second. Now, using the steady flow energy equation SFEE, we have our QI minus QO plus into bracket WI minus WO equals M into bracket H2, which is the variation in the entropy and the variation of the kinetic plus the variation in the potential energy. Now, from our steady flow energy equation, we are not given the QI, so it's cancelled. There's no work done on the nozzle. It has to be cancelled. Now we have the variation in the entropy. We have the variation in the kinetic energy, but we don't have the variation in potential energy, so that's cancelled. Now we are not given the mass flow rate, that's cancelled too. So from here we have our Q negative out, that is the heat energy lost, Q out, equal CP from the variation in entropy, that gives us CP T2 minus T1 plus the variation in the kinetic energy. Now, don't let us forget the heat lost from the nozzle equals 15,000 joules. Our CP, which is 1.0 multiplied by 10 raised to power 3 into bracket our T2, which we have to find, minus T1 223 into bracket plus our V2, which is 348 squared minus V1 136 squared, over 2. So that gives us minus 15,000 equals 1,000 T2 minus 223 into bracket plus 34A squared minus 130 squared over 2. From here, we're asked to find the T2. Our T2 becomes 156.69 calculated. Now our T2 equals 156.7 Celsius. So therefore, the exit temperature of the air exiting the jet nozzle equals 156.7 Celsius calculated. Thank you very much.